This is Britt Kessel with another example video. In today's video, I'm covering example 1 from lesson 8-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to relate c to the graph of f of x equals ax squared plus bx plus c. Remember, we call this the standard form of a quadratic. Okay, you guys know standard form because you've seen it when we factored. So I just want to tell you what information C tells you about the graph. Alright, now the biggest thing to know is to look at this kind of graphic that's on here and make sure that you're aware of some of the formulas. So the first formula that's on here that's kind of a big deal is the formula for the axis of symmetry. Okay, and I know that we're trying to focus on C here, which I'm going to show you here in just a moment. But I also want you to make sure that you know about the axis of symmetry because it's a big deal. Okay, I'm kind of squishing them together. Sorry. So the axis of symmetry lies on the equation x equals negative b over 2a. And so your axis of symmetry is going to be a vertical line that lays somewhere on the graph. I don't really know, I'm just picking a spot. But what that axis of symmetry does is it makes it to where when you determine what C is, it makes it to where you can reflect it very quickly. Okay, so that's why it's kind of important to note what the axis of symmetry is before we really get into, finding your y-intercept. So what I want to do is I want to actually use the try it to help to explain this concept. Okay, so I'm going to be plugging in, a 0 into my function, and I want you to see what happens. So everywhere where there's an x, I'm putting a 0. Well, when you multiply by 0, whatever you're multiplying to 0, it equals 0. So this first term, a times 0 squared, cancels out because 0 times anything is 0. That same thing happens here for b. So if you notice, f of 0, so when I plug 0 into the function, I get c. That means that your y-intercept value is equal to whatever your c is. Alright, so it's going to kind of move up and down on the graph, kind of just wherever C happens to fall. And so you can then reflect it across your axis of symmetry and kind of draw your parabola. So there we have it, guys. That is relating C to the graph of the function. Until next time.